So now that we've gone over all the different types of factoring, we're going to do a variety of problems where we have to decide when to use what. Now, if you remember, the very first step in factoring, if you can, is to factor out a greatest common factor. Okay, so after you factor out the greatest common factor, the next thing you want to do is you want to look and say, well, do I have two terms? If I have two terms, do I have dots? So for example, dots would be x squared minus 25. Okay, so this is a difference, because we have a minus sign, of perfect squares. Okay, these are both perfect squares. When you do, you just set up two sets of parentheses, and we put the square root of our first term right here in the first spot in each parenthesis. Then we make our signs plus and minus, and we put the square root of the second term in the second spot in each parenthesis. And there you have it. Okay, now, after you've tried to factor out a greatest common factor, sometimes you're going to be left with three terms, which we call a trinomial. So if you have a trinomial, I'm going to make one up here. Let's say we have x squared plus 7x plus 10. Okay, I'm trying to make easy examples to start. Now, what we're going to do is whenever the number in front of the x squared, we call that the leading coefficient, whenever the leading coefficient is 1, we set up two sets of parentheses. And since this is an x squared, I'm going to put an x and an x in the first spot in each parenthesis, because x times x is x squared. If this was, let's say, x to the fourth, you would put an x squared in each spot. And then we're just going to come up with two numbers that add to our middle term and multiply to the last term. So positive 5 and positive 2. Okay, now let's say, for example, I'm going to actually just kind of put a little barrier line there. Let's say, for example, we had a trinomial with three terms, just like this. Okay, that's what a trinomial is. But this time, let's say our leading coefficient wasn't a 1. So, for example, let's say we have 2x squared minus 7x minus 4. Well, in this case, we don't just jump right into setting up two sets of parentheses. What we're going to have to do is we're going to have to do the rainbow. Now, when you do the rainbow, don't set up two sets of parentheses. You bring down the first term, so the 2x squared. I'm going to leave a big space right here in the middle, and we're going to bring down this last term. Now, what we do is we come up with two numbers that multiply to the rainbow number. So 2 times negative 4 is negative 8. So we're going to find two numbers that multiply to negative 8 and add to negative 7. So negative 8 and positive 1. So negative 8 and positive 1. Now, since this middle term has an x on it, we need to attach x's to each of these. And once we've created our four terms, we're going to group and group. Now, out of the first two terms, you want to say, what is my greatest common factor? What could I pull out of these? Well, I could pull out a 2 as well as an x. So if I pull out a 2x, that leaves me with x minus 4 in parentheses. Okay, now here, I mean, really there's nothing I can pull out, but I have to show I'm pulling out something. So I'm going to really just pull out a positive 1. Now, a common mistake I see a lot of people write is, oh, if they factor out a positive 1, they just put a 1 here and then open the parentheses. Make sure you put the plus sign before the 1 so that you separate this expression here from what we're going to write over here. Now, if you pull out a 1, this stays exactly the same. So I'm going to bring down the x minus 4. And then to finish here, we're just going to take what's in front of our parentheses, the 2x and the plus 1, and I'm going to group them together in one parenthesis. And then I'm going to take my common binomial. Remember, these should always match in the parentheses, and I'm going to rewrite that just once. Okay, so just to kind of recap, if you have a number other than 1 in front of your trinomial and you can't factor it out, you would do factor by grouping. If you have a 1 in front of your trinomial, like we see up here, then all we do is set up 2 sets of parentheses, and we do the AM method. Okay, if we have more than 3 terms, so we've done ones with 4 terms, we've done ones with 6 terms, you could do one with more terms than that. What we're going to do is we're going to do grouping. Okay, so with grouping, I'm just doing one with 4 terms, but you would just group together the first 2 terms, group together the last 2 terms, and you would look and say, well, what's the GCF out of these first 2 terms? Well, I have a 2 and a 3, so all I could really pull out number-wise is a 1. But look at this, they both contain x's. This only contains one x, so I'm just going to pull out an x, and then write what I'm left with in parentheses. So I'd be left with 2x plus 3y. Now out of the next 2 terms, first of all, they both have negatives, right? And if you look in my parentheses here, I have positives. I want to be left with a positive 2x and a positive 3y in parentheses. So in order to do that, I'm going to have to pull out this negative sign. And also, the biggest number that divides evenly into 8 and into 12 would be 4. So I'm going to pull out a negative 4. Now if we look, both of these terms also contain y. So I'm going to pull out a y. And I'm only going to pull out 1 because that term only contains 1. Okay, so then in my parentheses, what I'm going to be left with is, when you pull something out, you just divide. Negative 8 divided by negative 4 is positive 2. I had an x, and I did not pull it out, so I need to include the x here. And I had a y, and I pulled it out, so I don't need to write it here. Okay, then negative 12 divided by negative 4 is positive 3. And y squared means I had 2 y's being multiplied together, but I took one of them out, so it still leaves me 1 to put in here. Okay, so now that we see that these parentheses match up, we know we're on the right track. So I'm going to group together what's outside the parentheses, the x minus 4y, and that'll be my first factor. And then I'm going to rewrite my common binomial. Okay, so if you can turn to page 11 of your packet, I'm going to go through the examples from practice with factoring. Okay, so number 1. Well, we can see here that we have a trinomial, and the leading coefficient, tri means 3 terms, and the leading coefficient is a 1. So when that happens, we set up 2 sets of parentheses. Since this is an x squared, I'm going to put an x in the first spot in each parenthesis, and I just have to do the AM method. I have to come up with 2 numbers that add to negative 13 and multiply to negative 30. Now, be careful. I know a lot of you might be thinking to use the numbers 10 and 3, but since they multiply to a negative, if we use, let's say, a negative 10 and a positive 3, that adds to negative 7, not negative 13. And if we use a positive 10 and a negative 3, that adds to positive 7, not negative 13. So the 2 numbers that actually work in this case are negative 15 and positive 2. Okay, so there we go. Number 2. I know a lot of you may be looking at this and saying, oh, look, this is dots. Well, you are right, this is dots. So some of you may say, let me just factor this to 10 plus 2x and 10 minus 2x. Now, the only problem with that is we have a greatest common factor. Okay, look at this. 4 divides evenly into both of these terms. So remember, your first step is factor out the greatest common factor. So if I pull out a 4, 100 divided by 4 is 25. And then I'll bring down the subtraction sign. And here, I've already taken the 4 out, or 4 divided by 4 is 1. But we still have this x squared, so I'm going to bring that down. Okay, after we factor out the greatest common factor, if I look, I say, look, I could still factor further. I have 2 terms. So is this dots? Yes, it is. It's a difference, and both of these are perfect squares. So when that happens, to factor dots, we set up 2 sets of parentheses, and the square root of the first term, so the square root of 25 is 5, so I'm going to put that in the first spot in each parenthesis, not the second spot. Okay, if this comes first, put the 5 first. And then my signs are going to be plus and minus, and then the square root of x squared is just x. Now, don't forget to bring this 4 down because that's part of your answer. and this would be our final answer. One thing I want to point out, I'm just going to put or. I know some of you guys first like to rearrange the order so the exponents go in descending order. So if you want to put the negative 4x squared first, and then the positive 100, you can do that. Now, here, if you do it this way, instead of factoring out a positive 4, remember, if our first term is a negative, you're going to want to factor out a negative along with the 4. So if we factor out a negative 4, and let me just say that again. When deciding when to factor out a positive 4 or a negative 4, okay, if your expression starts with a negative, factor out the negative. Here, if you left it in this order, your expression started with a positive, so you factor out a positive. It just makes it easier to factor that way. Okay, so anyway, here when we factor out a negative 4, we took the negative 4 and brought it out. So in parentheses, we're going to have x squared. And then 100 divided by negative 4 is negative 25. Okay, now, this in here is dots, so we can factor this further. So with dots, we set up 2 sets of parentheses. And the square root of x squared is x, so we put that in the first spot in each parenthesis. Make 1 plus, 1 minus, and the square root of 25 is 5, so we put that in the second spot in each parenthesis. And then again, take the negative 4 and bring it down. Now, even though these answers look different, they are definitely equivalent to each other. Okay, so number 3. Now remember, our first step in factoring is, can we factor out a greatest common factor? So when we look here, yeah, look, they both contain an x. So I'm going to pull out an x, and that would leave me with x minus 3 in parentheses. Now if I look at what I'm left with in parentheses, if you have 2 terms, the only way to factor further is if you have dots, a difference of perfect squares, and neither one of these is a perfect square. So we can't factor further. So believe it or not, that's it. That's our answer. Okay, factor out the GCF, and we're done. Okay, number 4. The first thing you want to say to yourself is, can I factor out a greatest common factor? Well, other than 1, there's really nothing you could factor out of these 3 terms. You can't even factor out a b because this last term doesn't contain a b. Okay, so now we have a trinomial, and our leading coefficient is something other than a 1. So when that happens, we don't set up 2 sets of parentheses. What we're going to do is we're going to do the rainbow and factor by grouping. So when that happens, we bring down our first term. I'm going to leave a big space and bring down the last term. And then I have to come up with 2 numbers that multiply to the rainbow number. The rainbow number is what you get when you take the product of 6 and negative 12. So 6 times negative 12 is negative 72. So I'm coming up with 2 numbers that multiply to negative 72 and add to, well, there's really a negative 1 in front of this b, so they're going to add to negative 1. Okay, so negative 9, positive 8. So I'm going to put a negative 9 and a positive 8. And because this has a b on it, I need to attach a b to both of these 2 terms. The reason we're allowed to do this is because this 4-term polynomial is equivalent to this trinomial. Think about it. If you combined your like terms here, right, is it negative 9b plus 8b just negative 1b? Okay, so this is equivalent to that. Now the reason we create this into 4 terms is so that we can group. So we're going to factor out the greatest common factor out of these first 2 terms, which would be 3b. Okay, 3 is the biggest number that divides evenly into both of these. And since they both contain at least one b, we're going to take out a b. Okay, so then in parentheses, 6 divided by 3 is 2. And we had 2 b's being multiplied together, right? B times b, and we took one of them out, so that's going to leave us 1 to put here. Okay, now I'm going to bring down the minus sign. 9 divided by 3 is 3. And we had a b, but we took it out, so we don't want to put it in here. Okay, by the way, that's a 3. That's a pretty funky looking 3. Okay, now if we look at the next 2 terms here, the only thing we could factor out is a 4. So you want to think about, am I going to factor out a positive 4 or a negative 4? Well, I want this parenthesis to match up with what I'm going to be left with in parentheses here. Since these go positive, negative, and these also go positive, negative, we want the signs to stay the same. So we're going to factor out a positive 4. So if I factor out a positive 4, positive 8b divided by positive 4 is positive 2b, right? 8 divided by 4 is 2, and the b we didn't take out, so we're going to have to put here, so 2b. And then negative 12 divided by negative 4 is negative 3. Okay, so you can see that these match up, which is what we want to happen. So what we're going to do is to create our factors. The first factor comes from what's on the outside of the parentheses, the 3b plus 4. And then the second factor comes from, you just rewrite the common binomial once, okay, not twice, just once, and that's the answer to number 4. Okay, so number 5, I know I saw some of you guys in class saw the 4 here and saw it was a trinomial and jumped right into doing the rainbow. I mean, technically you can do that and you can factor out the greatest common factor later, but if you can factor out a greatest common factor from the beginning, that's the first thing you're going to want to do. It's going to make your problems, it's going to make, your life so much easier to solve. So since they're all divisible by 4, right, you want to take out the biggest number that divides evenly into all of them, we're going to factor out a 4. Okay, so if you divide all these terms by 4, it's going to leave us with 1x to the 4th minus 1x squared minus 2. Okay, so all I did was 4 divided by 4 is 1. Same thing here, 4 divided by 4 is 1, 8 divided by 4 is 2, and I just brought down the signs. Okay, so now we want to look in our parentheses, and you want to say, can I factor further? If we had 2 terms, we'd look for dots. If we have 3 terms, we do trinomial factor, and if you had more than 3 terms, you would do grouping. So we have 3 terms. Now we have to decide, are we going to do the AM method, or are we going to do the rainbow method? Well, if you look, we have a 1 in front of our x to the 4th. So I'm not going to, could I do the rainbow method? Yes, but I'm not going to waste my time doing the rainbow method. It makes it a much more complicated problem, more room for error, and it takes a lot longer. So if you have a 1 in front of your first term in the trinomial, remember what we do is we set up 2 sets of parentheses. And I don't want to forget to bring this 4 down, so I'm just going to do it right now. Okay, now, since we have an x to the 4th here, we're going to put an x squared in the first term in each parenthesis, because x squared times x squared is what gives us that x to the 4th. And then all I have to do is come up with 2 numbers that add to the negative 1 that's in front of my x squared and multiply to negative 2. So that'll be negative 2 and positive 1. Now you want to look in your parentheses and say, can I factor further? If I have 2 terms, what I'm looking for is dots. Okay, this one doesn't have a difference. So even though the x squared and the 1 are perfect squares, we cannot factor further if there's an addition sign. This one has a difference, but although x squared is a perfect square, 2 isn't, so we can't factor further. You have to have a difference, and both terms have to be perfect squares. So this is our answer for number 5. All right, if you look at number 6, again, the first thing you can do is factor out a greatest common factor. All 3 of these numbers are divisible by 5, and since all terms contain x's, we can pull out an x. You can only pull out an x to the 1st because this term only has 1 of them. So I'm going to pull out a 5x. Okay, and when I do, remember 5 divided by 5 is 1. I had 5 x's being multiplied together, and I took 1 of them out, so I still have 4 x's being multiplied together. So I write that as x to the 4th. Okay, 45 divided by 5 is 9, positive 9. And I had 3 x's being multiplied together, and I took 1 of them out, so I still have 2 x's being multiplied together. So I write that as x squared. And then 100 divided by 5 is 20. And I had an x, but I took it out, so I don't have any left to put here. So I'm just going to close up my parentheses. Okay, so now within our parentheses, again, just like in number 5, we have a trinomial with a leading coefficient as 1, okay, just like we had over here. So when that happens, I'm going to first bring down my 5x, and to factor a trinomial whose leading coefficient is 1, I set up 2 sets of parentheses, And since this is an x to the fourth, again, we're going to put x squared in the first spot in each parenthesis. And I'm going to do the AM method. I'm going to come up with two numbers that add to 9 and multiply to 20. So positive 5, positive 4. Okay, now we want to look in our parentheses and say, can I factor further? So we have binomials, which the only thing you could do with binomials is dots. Now, in order to use dots, these would have to be subtraction signs. Like if this had x squared minus 4, we'd have a difference, and they'd both be perfect squares. We could factor further. But because of the addition sign in both of these, and also that's not a perfect square, we can't factor further. So this is our answer for number 6. Okay, so number 7. Now, again, the first thing you want to do with factoring is, if you can, you want to factor out a greatest common factor. So if I look at all of these, 24, 4, and negative 8, they're all divisible by 4. So the first thing I'm going to do is I'm going to pull out a 4. If I forget to do it in the beginning, I can do it later, but it's going to make my problem so much harder. So you're going to be dealing with bigger numbers, and I'm going to recommend that you just do it right from the beginning. Okay, so when I divide everything by 4, 24 divided by 4 is 6, bring down the x squared. 4 divided by 4 is 1, bring down the x. Negative 8 divided by 4 is negative 2. Okay, so now I want to look within my parentheses and say, can I factor this further? Now this is a trinomial, and the leading coefficient is something other than 1, so I'm not going to just set up 2 sets of parentheses. What I'm going to do is I'm going to have to do the rainbow. All right, so let me first take this 4 in front and just bring it down. I'm just going to make a big parenthesis here. When I do the rainbow, I bring down my first term, I bring down my last term, and I have to come up with two numbers that multiply to negative 12. Okay, I'm getting that negative 12 by multiplying the 6 and the negative 2. And they're also going to have to add to this number in front of the x, which is a 1. Okay, so two numbers that multiply to negative 12 and add to positive 1 would be positive 4 and negative 3. Okay, now, since this middle term has an x on it, I need to attach an x to each of these. So I'm going to put an x next to each of those. And from here, we now created a 4-term polynomial, so I can just do grouping. So let me first bring the 4 down, open up a parenthesis, and when I group these, I can pull out a 2x, which leaves me with 3x plus 2. Okay, if I look at my next two terms, I have a negative 3x and a negative 2. So the only thing you could pull out is either a positive 1 or a negative 1. Now, if we want to be left with a positive 3x and a positive 2 in parentheses, we need to pull that negative out. So what we're doing is we're pulling out the negative 1. So that's going to leave us with a positive 3x and a positive 2. Okay, so let me double close the parentheses. If you prefer to use like brackets like this instead on the outside, you can totally do that. Okay, so now let me bring the 4 down, and I'm going to take what's on the outside of my parentheses here, the 2x minus 1, and I'm going to group that together as my first factor. And I'm going to take this common binomial of 3x plus 2 and make that my last factor. Now, I mean, you always want to look in the parentheses and say, can I factor further? I mean, we have two terms, but neither one of these shows dots, shows a difference of perfect squares. So this would be my final answer. Okay, number 8. Now, number 8, first thing you want to say is, can I factor out a greatest common factor? And there's nothing that divides evenly into all 3 terms. So we're going to have to do, well, because there's a number other than 1 in front of the x squared, we're going to have to do the rainbow. So let me just kind of go like this to separate the work. So with the rainbow, we bring down the first term. We're going to leave a big space, and we're going to bring down the last term. Okay, now we need to come up with two numbers that multiply to the product of 9 and 4, which is 36. We've got to come up with two numbers that multiply to 36 and that add to negative 12. Okay, so negative 6 and negative 6. And since this term has an x on it, we're going to attach x's to each of these negative 6's. And from here, like we've been doing in some of the earlier problems, we're just going to group. So out of the first two terms, we could factor out a 3x which leaves you with 3x minus 2. I'm no longer going in as much detail about factoring out the greatest common factor because we've done that in the earlier problems. And out of these two terms, we either have to factor out a positive 2 or a negative 2. Now, if we want to be left with a positive 3x and a negative 2 in parentheses, since this goes plus minus and this goes minus plus, in order to be left with the same signs in the parentheses, right, we want these signs to switch up, so we're going to actually factor out a negative 2. And that'll work out for us because negative 6 divided by negative 2 is positive 3, and we can bring down the x. And positive 4 divided by negative 2 is negative 2. So you'll notice that these match up. Okay, so we're going to take what's on the outside of our parentheses, this 3x and this minus 2, and we'll group those together as our first factor. And then we'll rewrite the common binomial, the 3x minus 2, as our second factor. Now you can leave your answer like this, or if you want, when you have two of the same factors, I'm just going to write or, you can write it once, and because there's two of them being multiplied together, we can put a square on it, so either one of those answers are acceptable for number 8. Number 9, so the first thing you want to say to yourself is, can I pull out a greatest common factor? And when you look, we have a 3 and a 48, so yeah, you can pull out a 3. All right, so when you do, it leaves you with x squared minus, and then 48 divided by 3 is 16. Okay, so let's look at what we're left with. Now in here, we have a binomial, so we want to say, is this a difference? Yes, it is, of two perfect squares. Yes, both of these are perfect squares. So I'm going to bring down the 3, and to factor using dots, we set up two sets of parentheses. And since the square root of x to the 4th is x squared, I'm going to put that in the first spot in each parenthesis. Since the square root of 16 is 4, we'll put that in the second spot. And you can make a 1 plus and 1 minus. Okay, so let's still look. Can we still factor further? So again, we have two terms and two terms. Do we have a difference? No, we don't. Over here, do we have a difference? Yes, we do. Of perfect squares? Yes, we do. Remember, if it's an addition sign, you can't factor further. So let's bring the 3 down, and let's bring the x squared plus 4 down. But let's factor this x squared minus 4 further. So I'll set up two sets of parentheses. Since the square root of x squared is x, and since the square root of 4 is 2, we'll put that like that and make 1 plus and 1 minus. And if you look, this is the only one that has a difference, and these aren't perfect squares, so we can't factor further, so here's the answer to number 9. Okay, number 10. First thing you want to say to yourself, just like every single problem, can I factor out a GCF? Well, it was looking like we could maybe factor out an 8, but this doesn't have it. This only has a 1, so we can't do that. And we can't factor out any r's because the last term doesn't have it. So if you have, 4 or more terms, we're going to just do grouping. So I'm going to group together the first two terms and group together the last two terms. So out of the first two terms, I could pull out an 8 as well as an r squared. Okay, so then 8 divided by 8 is 1. If you want to put the 1, you can. Here, we have 3 r's being multiplied together, but we took 2 of them out, so we still have 1 r left over, so I'm going to put it here. And then bring down the minus sign. 64 divided by 8 is 8, and we had r squared, but we took the whole thing out, so there's no r's left to put in here, so I'm just going to close up my parentheses. Now, out of the last two terms, you could either factor out a positive 1 or a negative 1. But since we want to be left with a positive r and a negative 8, and here we have the opposite, we have a negative r and a positive 8, to get these signs to match up with these signs, we're going to actually pull out that negative. We're going to pull out a negative 1. And please make sure you write minus 1 here. So then negative r divided by negative 1, right? A negative divided by negative is positive, and r divided by 1 is r, so positive r. And then 8 divided by negative 1 is negative 8. Okay, so these match up, which is good. So let's see, I'm going to take what's on the outside of the parentheses, this 8r squared minus 1, and I'll group those together. and I'll rewrite the r minus 8 in a parenthesis. And that's my final answer. Oh wait, I should have said though, you do want to look to see if we could factor further. We do have a difference, and although 1 is a perfect square and r squared is a perfect square, 8 isn't. So that's why we can't factor further. And this is not dots either. Number 11. So the first thing you want to say to yourself is, can I factor out a greatest common factor? So if we look at all of the numbers, there's nothing that divides evenly into all 4 of them. And if we look at the variables, we can't factor any out because this term doesn't have an x. So since we have 4 terms, we're going to jump right into factor by grouping. So let's group together the first 2 terms and group together the last 2. So out of the first 2 terms, we can factor out a 3x squared. Okay, 3 is the biggest number that divides evenly into 6 and into 3. And then here we have 3 x's being multiplied together, and here we have 2 x's being multiplied together. So x squared is the most we could take out. All right, so let's write what we're left with in the parentheses. 6 divided by 3 is 2. And then we had 3 x's, and we took 2 of them out, so we still have an x to put here. And we can bring down the minus sign. And then 3 divided by 3 is 1. And we had an x squared, but we took the whole thing out, so we're not going to put any here, so we're just going to put the 1. So we have 2x minus 1. Okay, so then out of the next 2 terms, we could either factor out a positive 5 or a negative 5. Now, since this is a positive 2x and a negative 1, see the signs go plus, minus? Since these signs go minus, plus, they have the opposite of what's here. So we want to factor out a negative 5. If we have the opposite signs, we factor out a negative. That way, in parentheses, we'll get the signs to match up. So negative 10x divided by negative 5 is positive 2x. And then positive 5 divided by negative 5 is negative 1. Okay, so now all we have to do is just group together what's on the outside of the parentheses, so the 3x squared and the minus 5. And then we can rewrite this common binomial once. And that's our answer for number 11. Okay, so number 12, first thing you want to say to yourself is, can I factor out the greatest common factor? Yeah, totally. If you look at all these numbers, we have a 6, an 8, and a 2. They're all divisible by 2. So I'm going to just draw a line here. Let's pull out a 2. And if we divide each of these by 2, it'll leave us with 3m squared plus 4m plus 1. If you on accident forget to factor out a greatest common factor in the beginning, you can always do it later on in the end, but I don't recommend doing that because usually if you forget to in the beginning, chances are you're going to forget to in the end. And then also, if you factor it out earlier on, then you're dealing with smaller numbers throughout your problem. Okay, so anyway, I'm going to bring the 2 down. Now we have a trinomial, and the leading coefficient is something other than a 1, so that means we're going to have to do the rainbow. So when we do the rainbow, okay, let me just open this parenthesis. We bring down our first term. I'm going to leave a big space, and I'm going to bring down my last term. And I need to come up with 2 numbers that multiply to positive 3 and add to positive 4. So positive 3 and positive 1. And keep in mind, I attached m's to these because this is our middle term is an m. Okay, so now let me just bring down the 2 and the parenthesis. Actually, and you can use a bracket if you prefer. That's up to you. If you don't want to have parentheses within parentheses, you can always use a bracket. All right, so now let's group together the first 2 terms where I could pull out, let's see, a 3m. And then that's going to leave me with m plus, well, 3m divided by 3m is 1, so m plus 1. Now out of the second pair of terms, the only thing I can factor out of there is a positive 1, which also leaves me with, in parentheses, m plus 1. Okay, so close up the parenthesis, and then I'm going to close, I made it a bracket, so I'm going to close the bracket. Okay, so now I'm going to take this 2 and just bring it right down. And I'm going to group together what's on the outside of the parentheses, the 3m plus 1, to make my next factor. And then I'm going to write this common binomial of m plus 1 as my final factor. So there's the answer to number 12. The first thing we want to say to ourselves in number 13, just like every example, is, can I factor out a greatest common factor? And we can. So because we have a 1 in front of our first term, we are not going to do the rainbow. Technically you can, but it just creates way more work, which means there's more room for error. So when we have a 1 in front of our first term, when we have a trinomial, we just set up 2 sets of parentheses. And since our first term is an x to the 4th, we're going to put an x squared in the first spot in each parenthesis. And then we're going to do the AM method. Okay, we're going to come up with 2 numbers that add to negative 13 and multiply to negative 42. So negative 6, negative 7. Now if we look in our parentheses, we see we have a difference, but neither one of these is a perfect square, so we don't have dots. So that's it. There's our final answer. Okay, now with number 14, you want to say, can I factor out a greatest common factor of all 6 terms? No, we can't. So we could either, with 6 terms, we could either group it into 3 and 3 or 2, 2, and 2. Okay, I'm going to actually start with 3 and 3. If I group it into 3 and 3, okay, out of the first 3 terms, the only thing I can factor out is an x squared, which would leave me with x plus 5 minus 8, which that looks a little funky because these are like terms which could be combined. But let's just see what happens. So if I factor out of these terms, the only thing I can factor out of these is a 1 or a negative 1. But what's going to happen, you'll see, is if I do, let me factor out a negative 1. I'm going to be left with 40x minus 7x minus 35, which you'll see right away, these are not the same. Okay, these are not equal. So since those are not the same, what that tells us is grouping it into 2 groups of 3 didn't work. So let's try 3 groups of 2. All right, so let's group together the first 2, group together the next 2, and group together the last 2. Okay, out of the first 2 terms, I can pull out an x squared, which leaves me with an x plus 5 in parentheses. Okay, out of the next 2 terms, I can either pull out a positive 8x or a negative 8x. Well, since this is a positive and this is a positive, and here the signs don't match up, it goes negative, negative, what that tells us is if we have opposite signs here, then what we have here, it means we want to factor out a negative. So I'm going to factor out a negative 8x, which also leaves me with x plus 5, because negative 8 divided by negative 8 is 1, and I had 2 x's and I pulled 1 out, so I still have an x to put in here. And then negative 40 divided by negative 8 is positive 5. And I had an x, but I already took it out, so I'm going to close up my parentheses. Okay, out of the last 2 terms, it looks like I could factor out a positive 7, which would also leave me with x plus 5. Okay, so now I'm going to take what's on the outside of my parentheses, and I'm going to group those together. So that gives me x squared minus 8x plus 7, and I'm going to bring down that common binomial factor of x plus 5. Okay, so now we want to look and say, well, can I factor further? Well, this is a trinomial, and the leading coefficient is a 1. So we would set up 2 sets of parentheses, and since we have an x squared right here, I'm going to put an x in the first spot in each parenthesis, and as long as I can come up with 2 numbers that add to negative 8 and multiply to positive 7, we can factor further, and we do. We have a negative 7 and a negative 1. And then just bring down the x plus 5. Okay, and that is our final answer. Number 15, I know some of you guys got tricked on this one, but I mean, you're going to start it the same way we start them all. Can I factor out a greatest common factor? Yes. 16 divides evenly into 16 and 64. And then if we look at our variables, they both contain x's, so we're going to pull out the one with the lower exponent, which is x squared. So we'll factor out a 16 x squared. Okay, so what that's going to leave me with in parentheses, well, I had a 16, I took it out. I had 8 x's, and I took 2 of them out, so I still have 6 x's. And I had 6 y's, and I didn't take any of them out, so I got to put those 6 y's left in the parenthesis. And then bring down the minus sign. 64 divided by 16 is 4. I had an x squared, but I took out all the x's. I have 12 z's being multiplied together, and I didn't take any of them out, so I got to put them all right here. Okay, so now we're left with two terms in parentheses. So we want to say, is this a difference? Yes, it is, of perfect squares. Well, yeah, as long as your exponents are even, then they're perfect squares. Okay, so the square root of x to the 6th is x cubed, because x cubed times x cubed gives you x to the 6th. Just like the square root of y to the 6th would be y cubed. Okay, so anyway, let's set up our, well, let me first bring down the 16x squared. And I'll set up my two sets of parentheses. And since the square root of x to the 6th, y to the 6th is x cubed, y cubed, I'm going to put that in the first spot in each parenthesis. We know we're going to make 1 plus and 1 minus. Okay, and then the square root of 4z to the 12th would be 2z to the 6th. I mean, basically to take the square root of something that has an exponent, you just cut the exponent in half. Okay, so now we want to still look at our parentheses. I can't do anything with this because it's two terms with a plus sign. But here I have two terms with a minus sign. I want to say, is this a difference of perfect squares? Well, unfortunately, it's not, because these are odd. Or maybe fortunately it's not, because these are odd. Then it tells us we're done. All right, so this is our answer. Okay, number 16. I did see some people jump right into the rainbow, but remember, what's our first step in factoring? GCF. If you could pull out a greatest common factor, you want to do that first. So in number 16, we can pull a 3 out of each term, which would leave us with x squared plus 5x plus 6 in parentheses. All right, so I'm just going to bring the 3 down, and this is a pretty straightforward factoring problem. If we have a trinomial whose leading coefficient is a 1, we set up two sets of parentheses. Since our trinomial starts with an x squared, we're going to put an x in the first spot in each parenthesis, because x times x gives us x squared, and then we're just going to do the AM method. So two numbers that add to 5 and multiply to 6 are just positive 3 and positive 2. So that one actually wasn't too bad. Number 17, can I pull out a greatest common factor? Yeah, you sure can. You could pull a 2 out of each of these terms. So if you do, that would leave you with 3x to the 10th minus 2x to the 5th minus 5. Okay, so now we have a trinomial. So we want to see if we could factor this further. Since the leading coefficient is something other than a 1, we're going to have to do the rainbow. So remember, with the rainbow, we do not set up two sets of parentheses underneath. What we do is well, let me bring down the 2 first. I'm going to use brackets. We bring down the first term. I'm going to leave a big space, and then I'm going to bring down the last term. Okay, so from here, we're going to find our rainbow number, okay, which we multiply the 3 and the negative 5, which gives us negative 15. So we need to come up with two numbers that multiply to negative 15, okay, we'll do that, and add to negative 2. So negative 5, positive 3. I'm going to actually just put the positive 3 first, and the negative 5 second. Now what's really important is, since this middle term here has an x to the 5th, we need to attach x to the 5ths to both of these. And I mean, the reason we do that is because you want this expression to be equivalent to this expression. If you combine your like terms here, negative 3x to the 5th minus 5x to the 5th would be negative 2x to the 5th, which is what it says right there. Okay, but anyway, let's keep factoring. So I'm going to take my 2 and bring it down. And now I need to do grouping. Out of the first two terms, it looks like I could take out a 3x to the 5th. Okay, when I do, well, I've taken the 3 out, and out of these 10x's, I've taken out 5, so I still have 5x's being multiplied together left here. So I'm going to write x to the 5th. And then plus 3x to the 5th divided by itself is 1. Okay, out of these next two terms, you could either take out a positive 5 or a negative 5. Well, since this goes plus plus, and this goes minus minus, remember, if they have the opposite signs here as what we have here, we want to take that negative out. So I'm going to take out a negative 5, which is going to leave me with a positive x to the 5th, and negative 5 divided by negative 5 is positive 1. Okay, so now we can just bring down the 2, we can take this 3x to the 5th and the minus 5 and put them together. And we can rewrite our common binomial of x to the 5th plus 1. So there's our answer for number 17. All right, number 18. I know when I went around in class, a lot of people didn't realize that there was a GCF, but I mean, look at all 4 of these terms. You can pull a 2 out of every term, and you can pull an x out of every term. So I'm going to pull out a 2x. Okay, and that's going to leave me with x cubed plus 4x squared minus 9x minus 36. Okay, so now we want to look in our parentheses and say, can I factor further? Well, I have 4 terms, so I'm going to do factor by grouping. All right, so let me bring down the 2x. I'm going to use brackets. You can use parentheses if you want. Now, out of the first 2 terms, I can pull out an x squared, which leaves me with x plus 4. Okay, out of the next 2 terms, I'm going to want to pull out a negative 9, which also leaves me with positive x and positive 4. It's always nice when you have the same thing in the parentheses, because then you know you're on the right track. Okay, so let me just bring down my 2x, and I'm going to group the x squared minus 9, what's on the outside of those parentheses, together, and I'll bring down that common binomial of x plus 4. Okay, now, if you notice, we have a difference, and both of these are perfect squares. Okay, we should always be looking for this. Like if you look back at number 17, we have a difference, but we didn't have perfect squares, so we couldn't factor further. But here, this is dots. So x squared minus 9 would factor to x plus 3 and x minus 3. Okay, it's just dots. And then you could bring your 2x down, and you can bring down the x plus 4. And at this point, nothing factors further, so this would be our final answer. Okay, number 19, the first thing you want to say to yourself, like always, is can I factor out a greatest common factor? So if you look at all 6 of these terms, there is nothing that we could factor out of all of them. So what we have to do is decide, are we going to group this into 2, 2, and 2, or are we going to group it into 3 and 3? Now, some of you might be able to look ahead and know right away what to group it into. Okay, let me start with 3 and 3. So if I were to group this into 2 groups of 3, and I'm going to do this quickly, what you'll notice is what you can factor out of the first 3 terms is an x squared, which leaves you with x squared minus 9 minus x. Now, out of the last 3 terms, you could factor out nothing, just a 1. So if we factor out a 1, it's going to leave us with the same thing, which these are not the same, okay? They don't match. So what that means is instead of grouping it into 2 groups of 3, we're going to group it into 3 groups of 2. All right, so let's group the first 2, the next 2, and the last 2. So out of the first 2 terms, we can factor out an x squared, which leaves us with x squared minus 9. Okay, out of the next 2, you have to decide whether you want to factor out a positive x or a negative x. Now, since in here we have a positive x squared and a negative 9, since the signs go plus, minus, and these do the opposite, it goes minus, plus. When it has the opposite signs of what's in our parentheses, it tells us we want to factor out a negative. So I know I'm going to factor out a negative x. Okay, because a negative divided by a negative is a positive, and if we had 3 x's and we took 1 out, we still have 2, so we write them as x squared. And then a positive 9x divided by a negative 1x would be negative 9. All right, so far, so good. The parentheses are matching up. Now, out of the last 2 terms, we're going to factor out a negative 20, which is also going to leave us with a positive x squared and a negative 9. Okay, so this is good. So we're going to take what's on the outside of each of these and group those together. So we'll have x squared minus x minus 20, And you could take that common binomial of x squared minus 9 and bring that down. Okay, so now we want to look and say, well, what can we factor further? Well, here we have a trinomial. The leading coefficient is 1. So as long as we have two numbers that add to -1 and multiply to -20, we can factor further. And we do. So let's set up two sets of parentheses. Since this is an x squared, we're going to put an x in the first spot in each parenthesis. And then two numbers that multiply to -20 and add to -1 would be -5 and +4. Okay, now here, this is just dots, right? Difference of perfect squares. So we set up two sets of parentheses. The square root of x squared is x. We have 1 plus 1 minus, and the square root of 9 is 3. All right, so you could look and say, well, can we factor further? But, I mean, all these binomials, we don't have any x's being squared. So none of them are a difference of perfect squares, so this would be our final answer. Okay, number 20. So again, the first thing you want to say to yourself is you want to look at all 6 of these terms and say, can I factor out a greatest common factor? Well, no, unfortunately I can't. So you have to decide, do I want to group it into 2 groups of 3 or 3 groups of 2? Now, some of you guys will be able to tell just by looking at it what's going to, give you the same thing in the parentheses. All right, it seems like I always start off with the wrong one, so let's see. So I'm going to do 3 groups of 2. Let's see if that's right. Out of the first 2 terms, I could factor out a 5x cubed, which in parentheses would leave me with x minus 6. Now, out of the next 2 terms, I mean, you could clearly see right away this is not going to work, because out of the next 2 terms, if I factor out, let's say, a 2x squared, that's going to leave me with 20 minus 1. These don't match. I'm just going to stop right here. And instead of grouping it into 3 groups of 2, let's group it into 2 groups of 3. Okay, so I'm going to group together the first 3 terms and then the last 3 terms. All right, out of the first 3 terms, it looks like I could pull out a 5x squared. Okay, 5 is the biggest number that divides evenly into all of these. And you want to look with the x's, which has the smallest exponent. Okay, so then in parentheses, that's going to leave me with x squared minus 6x plus 8. And then out of the last 3 terms, I either want to factor out a -2 or a +2. Now, since these signs go plus, minus, plus, and these do the opposite, they go minus, plus, minus. Remember, for the opposite signs, we're going to factor out a negative. So I'm going to factor out a -2, which would leave me with positive x squared minus 6x plus 8. Okay, awesome. So now take what's on the outside of the parentheses, so the 5x squared and the minus 2, and you can group those together, and then we'll rewrite that common trinomial, x squared minus 6x plus 8. Okay, so if we want to see if we can factor further, here we have a binomial. So we have a difference, but neither one of these are perfect squares, so we can't do anything with that. All right, this is a trinomial, and since we have a leading coefficient of 1, as long as we combine 2 numbers that add to -6 and that multiply to +8, then we can factor further. And we can do that. So set up 2 sets of parentheses. I'll put an x and an x, and the 2 numbers that multiply to -8 and add to -6 are -4 and -2. And then don't forget to bring down this factor that couldn't factor further of 5x squared minus 2. Now if you look and you want to say, oh, look, we have a difference, and 4 is a perfect square, but x is not, so we can't factor further. So none of these, if you look at these, can be factored further. So there's our answer for number 20.